Imagine building the software that controls a space rocket. The stakes are as high as they get. A single error could be disastrous, which is why that code requires years of rigorous testing before it ever leaves the ground. Now, compare that to building a simple calculator app for a smartphone. It's a tiny project. A small team can write the code quickly, and if there's a bug, the risks are completely harmless. This brings up a question that every software company has to face. Should the team building the calculator use the exact same step-by-step construction plan as the rocket engineers? Because the scale and danger of these projects are so wildly different, one single development method cannot fit every project. Think of it like building a house. An architect doesn't just start pouring concrete and nailing boards together. They need a blueprint first, so they understand exactly what to build, how to build it, and in what order to do the work. In software engineering, our blueprint starts with the Software Development Lifecycle, or SDLC. This diagram shows the standard phases required to build any program, like planning, designing, coding, and testing. It tells us what activities need to be done. But having a list of chores doesn't tell us how to do them. A software process model takes those phases and organizes them into a specific step-by-step framework. Every software project has the exact same final destination: finished working code. The process model you choose is simply the route you take to get there. So how do you pick a route? Well, if you have a project where every single requirement is set in stone from day one, and the customer knows exactly what they want, you can take a very direct path. This chart shows the waterfall model. Notice how the flow moves strictly downward. Developers finish one phase entirely before stepping down to the next, and they never go back up. But what if your customer only has a vague idea of what they want? If the final goal is a bit blurry, a rigid one-way street will cause a lot of frustration. Here we see the prototype model. Instead of trying to build the final, perfect software right out of the gate, you build a quick, basic sample, a prototype, and immediately show it to the customer for their feedback. You incorporate their notes, improve the sample, and repeat this loop. You keep looping until the requirements are crystal clear, and only then do you build the final product. The amount of clarity you have at the beginning of your project dictates whether you can lock in a strict one-way path or if you need a flexible, sample-based loop. Now, imagine a customer who wants their software launched as quickly as possible. They need something working right away, but they are perfectly willing to accept updates and new features later on. This diagram illustrates the evolutionary model. You build the software little by little. You launch a small version 1, and then sequentially expand into larger, more capable versions over time. Let's jump back to those massive, extreme stakes projects, like aircraft controls or rocket software. Moving fast or guessing what the customer wants isn't an option when failure is catastrophic. This graphic shows the spiral model. Development happens in repeated cycles, but the heavy focus here is on this specific section: risk analysis. In this model, the project only expands outward into a wider loop after potential dangers are meticulously identified and managed during every single cycle. Large-scale software requires a process model that actively manages growth and identifies potential dangers at every critical step. You can think of these 4 models as a strategic toolkit. Matching the specific model to the needs of the customer dictates whether a project succeeds or fails. This matrix brings it together. Fixed requirements get the strict downward flow of waterfall. Unclear requirements get the feedback loop of prototype. Fast launches get the expanding blocks of evolutionary. And high-risk systems rely on the careful outward loops of the spiral model. Before we move forward, let's clear up a common roadblock for beginners. It is very easy to mix up 3 terms: software process, SDLC, and process model. Here is a simple visual to keep them separate. The software process just asks what activities are being done. The SDLC is the complete journey, from the first idea to long-term maintenance. And the process model is how that journey is performed. Now that you understand the map, we are going to explore the very first route ever charted, the Waterfall model. It's the oldest model of them all and incredibly important to software history. At first glance, it looks beautifully simple. But there is a catch hidden in that one-way street that makes it surprisingly rare in modern development. We'll find out why next.